Hello and welcome to How to Make Your Water Budget. Now here we are given this table containing the precipitation for each month here, listed above, and the potential evaporation for each month, listed here. Now to start off we have to fill out this entire table. The easiest part to fill out the totals. Now using my amazing math skills, I know that this is 1,433 and that this is 1,032. These can be found by simply just adding up all the terms in each of the columns. Next, we have the row precipitation minus potential evaporation. This is pretty simple to figure out. All you have to do is just subtract the top number from the bottom number. So for example, here would be 127 minus 15, or 112. It would be 133 minus 18, or 115, and so on. So now we'll just fill this up. Now that we have filled out the precipitation minus potential evaporation row, we can move on to the storage row here. We will do the delta storage later. Now, seeing as for the final few months, the precipitation minus potential evaporation is pretty high, we will assume that given if we were to bring this around, the storage would start off as 100. So I'll write that down. 100, and now adding 112 to 100, well, that still says this storage caps out at 100, so it continues to be 100, and then we keep on adding 100, 100. Now we get to our first negative, we subtract. So 97, now we subtract again, so that is 48. Then we subtract again, that's 5. Now we subtract 64, this is greater than 5, so, and storage levels off at 0, so this just goes down to 0. Now negative 56 goes to 0 again. 16, well, we're adding to 0, so this is 16, add that, this is 96, and here, well, caps out 100, so it goes back to 100. Like that. Now, using this row, we can figure out what the delta storage is. So now going from 100 to 100, that's 0, sorry, 100 to 100, that's 0, 100 to 100, again, that's 0, 100 to 100, 0, 100 to 100, 0, 100 to 97, that's negative 3. 97 to 49, that's 48, that's negative 49. 48 to 5, that's negative 43. 5 to 0, that's negative 5. 0 to 0, that's 0. 0 to 16, that's addition, so that's 16. 16 to 96, that's 80. And then 96 to 100, that's 4. Great. So now that we've gotten that, we can go on to the actual evaporation. Now, to get the actual evaporation, what we do is we simply just take the predicted evaporation and we subtract stuff if the storage is not enough, like for example around here. So starting off, we can just copy down the predicted evaporation. 45, 75, 122, 164, 179. Alright, so now we've gotten to our first 0. Starting off, we see we have 106 precipitation and 170 evaporation. Well, you can't evaporate more water than you have, so you can only evaporate 106 of the precipitation plus 5 from the storage over here. Thus, the actual evaporation is 106 plus 5, or 111. So here we have the same problem. The precipitation is simply not enough and is lesser than the evaporation, and there's nothing in storage, so that means that we can only take what precipitation has fallen to evaporate. Thus, the actual evaporation is only 73. Now, going on here, this is all less, so we can just copy it down again. 69, 31, 15, and then we will find our total, which I will do later. So, now, using my amazing math skills and totally not a calculator, I've calculated that the total of this actual evaporation is 917. You know, these numbers are actually pretty useless, but we'll fill them in anyway. So now we go into deficit. Now, deficit only occurs when the storage is 0 and we have to take out, and there is more evaporation than there is precipitation, for example, in this column. For the rest of the time, it's all 0. So here, 0, 0, 0, 0, 0, 0, 0. Now here we see that storage we're evaporating more than we can actually than we have in storage, and we have from precipitation. So then however much more that is than how much storage there is, that is our deficit. So here we have 170 minus 106, we have a 64 deficit, plus there's still 5 in storage, so we take that away, so therefore there is a 59 unit deficit here, because we're trying to take away, we have to take away 64 from the storage, but there's only 5 to take away, thus there's 59 that we take away from 0. Make sense? Good. Alright, so now we go here, where the difference is negative 56, and there's nothing to take away, so it's just the deficit of 56. And here we're adding, so 0, 0, 0. Add these together, that is 115. So now we go to our surplus. This only occurs when the storage is 100, and we are adding more water to the storage. This results in runoff, which just goes away from storage, and we'll call surplus. So here we're adding 112, so that's 112 surplus. Here 115, here 97, and here 59. And here's taking away, so we don't worry about those. Those are all 0 for obvious reasons. You aren't adding anything if you're taking away. And now we're adding 16. Well, storage isn't full, so this all goes into storage, and now it goes off into runoff, so therefore the surplus is still 0. Here, same thing, it's still filling up storage, so 0. Now here we're adding 137, and 4 of that goes into filling up storage. The other 133, that goes into surplus. So now our total is 516. So now let's go on to the graph. We are required to graph the precipitation, predicted evaporation, and actual evaporation on this plot right here. So I will go and plot those, and then we'll come back later to fill in the gaps. Alright, now you see I have graphed the 3 values are here. We have precipitation in pink, the predicted evaporation in yellow, and the actual evaporation in Sharpie black right here. Alright, so now we have to label the areas between these with surplus, deficit, usage, and recharge. Well, first of all here, all of this is beginning with storage at 100, so it's all surplus. So we can simply just draw some lines here to indicate that it is surplus. Alright, now that that is done, here is where we are taking water away from the storage. As you can see here, the storage is decreasing in these 3 months right here. This is where we are using the water right here, so it is usage. This goes up on to April, in which case we end up actually running out of water in the storage and becomes deficit. So we shall fill in this area here with this to represent usage. So then here is where we have a deficit. Actually, wait, here would be deficit too. Yeah. So basically here is where we would have a deficit. This would be all the water that would be evaporated but cannot be evaporated due to the fact that there's simply no water in storage. So deficit here is labeled as dot, so we just... This is really bad for my pencil. So yeah, basically just fill that place up to the heck with dots. Here. Alright, and now, finally, we have this part right here, which is where we are filling back the storage. And this is our recharge. So this goes up to around December, where we finally fill up the last bits. And then back into December from January, that is where we go from 100 to 100, that's just surplus again. So here, this is surplus. between December and January, and everything here, this is recharge. And there you are. You have filled out your table and you have graphed everything. I hope this tutorial helps, and have a great day, everyone.